Okay, on Insight, instead of going to our normal place where we would click Run Insight, we need to go to Bootstrap Confidence Intervals Construction. Okay, Run Selected Visual Inference Tool. In the same way, you need to import the data. So go looking, and all the data I give you on this topic, I'll save in the same place so we don't get confused. Year 13 stats, and when you get to this page, go to data sets, and under ADN stats data are all the possible CSV files you will need for this topic. If I just use the North Island sparrows, which is where we started yesterday, I'm going to input the 9 values, right? The 9 values that we did the bootstrapping with yesterday. Hopefully those 9 values are the same 9 values that you can see in front of you. Okay, and in the same way you can view the variables, the weight of the sparrows, and in this case they are all from the North Island. Down the bottom here you can select which variable you want to graph. Well, in the internal there'll be lots of choices, but for this example the only option you have is the weight. Okay, and over on the right here is a box and whisker plot and dot plot of the 9 samples of North Island sparrows in New Zealand. Okay, so the lowest weight was 25 grams, the maximum weight was 32 grams. From here you can click Analyze, and we are going to sample with replacement. We'll do it once, then we'll do it 5 times. Remember, you did it 10 times yesterday manually. So let me just show you once. You have to click this button here, Record My Choices. Before I do that, I should change this to median, because remember yesterday we used the median. We were always rather than the mean, so I'll stick with that. You could easily do it for the mean as well, but record my choices. The median of the sample was 29, right? Count in to the 5th one, 1, 2, 3, 4, 5, or you can count it from the bottom from the 5th one, 1, 2, 3, 4, 5, and the middle point of the sample is 29. Now, resampling, and I'll just do this once, and I'll animate it. Okay, so here are my 9 values on the left, and it's randomly selecting with replacement those 9 values, and it's plotted them down here with a new median. 29 got used once, 25, 30 didn't get used at all. This value got used 4 times, this value didn't get used, this value got used once, this value got used 3 times. Okay, so I resampled from the sample with replacement 9 times and got this distribution. Okay, and I have a new median, and that was one iteration of what you did yesterday. Okay, because you remember going across generating 9 random numbers, and each time all of the 9 values were able to be selected, so sometimes they got missed out and sometimes they got selected more than once. I could do that really quickly 5 times. Remember, it took you about 20 minutes to do it 10, or maybe 10 minutes to do it 10 times. This is doing it 5 times. Once, twice, 3 times, 4 times, keep on getting 29 as a median, 5 times. Oops, this is the 5th time. Okay, what you can't see in this diagram is the fact that we got 29, I think, 3 times as a median, 28 once, and 30 once. Okay, and then further down that sheet, I think most of us got between 27 grams and 30 grams. Is that right? The range of medians fell between 27 and 30 for most of us. Some people it was 26 and 30 and 27 and 31, but for the majority, I think 3 of the groups got 27 to 30. If you think about a sparrow, that's quite, you know, you can imagine different size sparrows. That's quite a wide range of median for the actual population, and the reason for that is this is a very small sample of North Island sparrows. And it's very easy to, if I increase that sample size, obviously this range would condense of the true population median. This function down here will use this scale down here, and what it does is it keeps an eye on how many times you got 29, for example. So if I just click go once, I'm just doing it one. Okay, it's doing the sampling, and then it's found the median is 29, and it's plotted one of the samples is 29. Make sense? I could repeat it 5 times. Okay, I'll do that now. Okay, and this is keeping track on how many times we get 29 and how many times we get some of the other values. So that was 5 iterations of sampling with replacement of one sample. And then we're building up a picture of what's happening in the, or what the true population median will fall between. So given the advantage of having a computer, we can actually do this 1,000 times quite quickly. Okay, and that's showing you just a sample of 9 values, resampling with replacement 1,000 times, and building up a picture for where the true population median will fall. Now in the example yesterday we took the lowest possible median and the maximum possible median, didn't we? And said the true population median will fall between those two limits. Well, that's fairly true, but in the internal, we're actually going to take a 95% confidence interval. So it's going to take the 29 from the sample and show that the true population median will actually fall between 27 and 31, and we're 95% confident of that. Okay, notice that there was one time where the median was 32 out of 1,000, and that's because the maximum value was 32. I would imagine, yeah, all 9 values, 32 was selected 9 times in that iteration to get that median of 32. Pretty unlikely, so that's only why it happened once. And down here we had a few times where it hit 25. There must be, yeah, there are 2 25s here. So maybe half a dozen times we struck getting 9 values of 25, hence the median was plotted at 25. Okay, the last little feature down here, it says Bootstrap distribution summary, and it just tells you what the mean of these 1,000 values are and how far they're spread out. Okay, the average distance from the center. So that sort of completes the information you'll need to be able to understand that, you know, this is a normal distribution. The middle point is 29, and that gives you an indication of how far spread the data is. So to sum up, and this is the conclusion you would have from this graph, the true population median weight of sparrows in the North Island fall between 27 and 31 grams, with, this is true 95% of the time. Or you could start off, I'm 95% confident of that, and finish the sentence. Okay? Remember, this is making a formal inference about a population. Okay, and this is the technique we use, it's called bootstrapping.